Okay. Yeah, like last time we were trying to get some music working, and um, the way I showed you is the way that it works, and it wasn't working on here last time. Did anybody try to do music on theirs at home?
Well, I did the music when I watched the video from last time. Or fine.
Yeah, I have no idea what. It's possible I had something muted on here or something, but I don't think I've changed anything. But in any case, it's working okay now. So we'll put a couple of music clips in today and associate it with some actions. Just to kind of get some one-off sounds. There's also some background music. So I went ahead, and to keep our theme, I created a folder in here called Mario Assets, and I went on to Google and just did a search for some Mario effects and found several different things. So the ones I went ahead and grabbed, I'm actually going to grab one more here. I downloaded it already. I just haven't put it in here. Is let's see, the You're Dead song or sound, whatever. So we'll go ahead and connect these to a couple of our actions that occur. So sounds can either be looped or they can be one-offs. So I do have the main Mario soundtrack here that'll play kind of in the background. So I did is I drug it into the scene, and I actually made it a. So if I click on it here, you see it. It's actually a game object. All right, so it's a empty game object with an audio source. And that audio source happens to have the main theme, Mario Dealy Flippy, attached to it. And I set it to play on awake, so it should automatically start playing for us. And then also go ahead and loop. And I turned the volume down on it a little bit so it wasn't just so overbearing. But in any case, then I made it a child of our player. Now, that should not matter, I don't believe, in the 2D scenes. In a 3D scene, audio actually plays at a position. By default, you can actually have it be over-encompassing in the world. But so the farther you are away from it, the less you'll hear it, to the point where you might not hear it at all. So I'm actually attaching it as a child to Mario. And what will happen if I do that? Yeah, it's now a component of Mario, and when Mario moves, the sound will move with him. So wherever Mario is, we'll hear, well, this is actually a dead baby, but we'll have the soundtrack. And I have this set on play awake and also to loop. So when it gets to the end, it'll play over again. So if I just hit play here, we should have the sound working. All right, so this is just happening in the background. Now, what we might want to happen is we might want, when Mario or with our baby jumps, to have the whole jump sound go off. So kind of fire some sounds. So I'm actually going to turn that volume down even a little more. Let's just make sure we can still hear it until it's working. Yeah, good enough. Okay, so now what I'm going to do is we're going to go to our player, and we're going to add an audio source to our player itself. So the main theme song, I made an empty game object and attached an audio source to that. You actually could just pull it off by just dragging your audio into the scene, and it'll generate a game object with an audio source attached. Because I didn't want that to necessarily be example being when Mario jumps, I want Mario to make a jump sound, but I don't necessarily want the background music to turn off. So I need to have two separate audio sources, one that's playing the background music continually, and then another one that's going to be kind of our baby sound effects. Okay, so I went ahead and on the player, I attached an audio source. And by default, we're not going to have anything on there, and we're also going to turn off the play on awake. Okay, so this dude is going to be the ability to play sound effects for us. So one of the sound effects we might have is that jump sound effect. So when we hit the space bar and we jump, we want to hear that that sound. So with that in mind, we're going to have to go ahead, and we can do it on our baby movement script, since that's where the sound effects are occurring. And let's go ahead and let's attach this sound to it as a public object. And let's just see what kind of, well, we'll be able to tell in here. So let's go into our code here. Okay. Scripts, baby movement. Okay, I'm going to go ahead and I'm going to give myself a private variable in here for audio source. Let's call this guy audio. And then underneath start, we'll say this dot audio is equal to this dot get component audio source. Okay, and then I want to test something here real quick. I'm going to say this dot audio dot, let's see, what is it? For our player, I need to figure out what kind of value audio clip takes. Clip is a audio clip. Okay. So up here in our public things, I'm going to create a public audio clip. We'll call this guy jump sound. And we'll create a public audio clip die sound. Just have two different sounds, jump sound and die sound. All right, let's go hook those up. So now our player has the baby movement thing, expects two different sounds. I'm going to connect under Mario assets. Jump sound is going to be this jump sound I downloaded. And death sound will be this death sound I downloaded. All right, so now what we want to do is whenever we actually add that force to make the baby jump, we also want to play as a one-off that that sound. So we'll have to set the audio source's clip equal to the particular clip we want to play and then tell it to play. So we go back into update. Here's our jump key. So if we should jump, this is where we set the animation. Then we add our force. And after we set the animation, I'm going to go ahead, I'm going to say this dot audio dot clip is equal to this dot jump sound. And this dot audio dot play. I think play one shot. All right, so we can play with the delay, or we can play one shot. Okay, play one shot allows us to not actually have to set the clip. So maybe that's actually going to be the faster way of doing this. So rather than setting the clip for this audio source, I'm going to say this dot audio dot play one shot. And that guy takes the clip that we want to play, which is this dot jump sound. My guess is that's probably at least as fast or faster. It might be literally a convenience for what we had previously done, set the clip, then play the clip. But it might actually be faster for just playing a single sound. All right, so now whenever we actually jump, so this is only when we're not currently jumping and we press the space key, we should animate some jumping, play a sound for jumping, and then actually jump. Sounds pretty Mario-esque, right? Okay. Similarly, we want to have our death sound. So when we come in here, let's see who is actually in charge of if we're alive, we do all this stuff. Here's our kill script. So if we are currently alive, then we want to die. So this is where we'll play that that sound. So we'll say this dot audio dot play one shot. What are we going to play on the one shot? This dot die sound. Okay, so we got a couple of different sounds playing. Now, for our homework today, we were supposed to kind of get the mushroomy type guy to pop up, right? So we're working on some, you could have done it with lerping or something like that we talked about last time. But as a starting point, we need something that we are going to be able to hit, right? So when we think about the Mario Brothers, and let me... let's see. I'm actually just going to, just for the time being, I want to take this enemy out of the scene. So you can do this by actually highlighting him and then just hitting this little check mark and he'll disappear. So he's still in there so we can replace him easily, but he just won't get in our way right now. So that way we can focus on what we're working on in here with the baby jumping. All right, so what we want to be able to do is we want to have, for instance, maybe in this area right here, this is going to hit a block, right, and turn into something. All right, so now using what we know right now, what are some ways we can accomplish that? What are some ways you did this? Okay, so do some sort of box collider. So maybe put another game object on there that has its renderer turned off. You know, so we're going to have something that looks like a kind of a box, and have its renderer off so we don't actually see it. So we actually have that guy overlaying on this, right? So it's there, and we'll have his render off, but we can still collide with it. So when we jump, we'll hit it, and then he'll show up. Okay, kind of start with that as a first point. So we need, let's go to Asset Store. And then, well, actually, we already have something that can suffice for that probably. Let's look at this sheet here. That's what we already have, right? So maybe that guy. That's our, I think it's actually a treasure chest, but mushrooms live in treasure chests in our world. All right, so we'll go ahead and drag that one guy out there. All right, and we're gonna call this power up container. And let's scale this a little bit to get it into a size that we can see. Oh, that didn't actually give us a size that we can see.
Did it on your face.
Oh, did I? Thank you. There we go. Now we can see it. And we'll go ahead and place this guy where we want it. All right, so now right now it's actually sitting behind that, right? So now we need to mess with our layer stuff to get it positioned where we want it to be positioned, because we'd like to see it in front of that guy. Okay, so let's go into our layers. And let's see. I'm going to go ahead and add a layer. So right now our background layer is layer 8. Everything else is happening behind that. I'm actually going to move that. And we'll just have a foreground layer. And here's all our floors. Let's make sure they're still listed as. So that guy is in the background. This guy is in the background. And then this guy we're going to have in the foreground. We're still behind it. Window. It's not hierarchy. Does it go the other? Maybe it goes the other way. Got that guy to the foreground layer. We didn't actually change the background layers. We're still behind.
Make sure in the sprite render on the floor the order in the layer is set at 0.
Well, but if it's in a different layer, it shouldn't make a difference.
It shouldn't matter, but sometimes it does seem to matter.
Okay.
But it looks like it is set to 0.
Well, so then based on that, if both of these guys are set to 0 and we set this one to 1, it might be that they have to go in the other order. Yeah, now it's in front. So it doesn't seem to. Oh, wait a minute. Oh, it looks like we needed to add a sorting layer, not just a layer, in order to make this a different thing. Yeah, so we have sorting layers for where things lay on top of each other. So I guess in this case, we could just pull it off with order within the same layer. So in actuality, having our floors living in the background layer and having this guy living in the foreground layer really has no impact on it whatsoever visually. It's an organizational tool. So in any case, we have this guy set as a 1. So under the sprite renderer, order in layer is a 1, where the floors, the order in layer was a 0. So this guy will show up in front of them. And we want this renderer to only turn on, so we'll disable it by default when we hit it with a box collider, or we hit a 2D box collider. So I'm going to go ahead and we're going to add a component, box collider 2D. All right, now I'm going to make this box collider just a little, well, let's see if it'll work as is. It might be that it's a little bit too small. I think I need to edge it down a little bit, just so it can definitely get hit. All right, we'll try that. And we're going to set this guy up as being a trigger. Actually, we could set him up as being a trigger, or that's probably the way we should do it, because we probably want this guy to be in charge of producing the mushroom or something like that. So we'll attach a script to him that knows how to do that stuff. So we'll make this guy a trigger, so that when we hit it, we can go ahead and say, turn your renderer on initially. So that we know we hit it. So let's go back here to our scripts. And we're going to create a C# script. We'll call this guy power up container. All right, and we're going to go ahead and add that script to our power up container. Let's go ahead and edit this. Okay, and we'll say on. Always does that. Let's kill Visual Studio, relaunch it, and then see if it. On trigger enter 2D. And so we're interested in whether or not we just collided with the player. We don't want other things to impact us. So let's go back here and look at our player, and we see our player has a tag of player with a capital P. So we're only interested in doing something associated with that. So we'll ask the question here, if collision.gameObject.tag is equal to player, then let's go ahead and turn our renderer on. So we'll say this dot get component sprite render dot enabled equals true. Okay. Come back in here. Make sure this guy is off by default. So we'll turn his renderer off. Box collider is on. He has the script attached to him, the power up container. And the box collider is a trigger, so that trigger should get hit. All right, so it turned into our, but we don't want it to just do that. We also want it to produce the thing, right? It's going to start doing its thing. So the starting point when we do that is we need to create a new object. Now, couple things you could have done. You could have had that object sitting there, also invisible, right? Already had it in the scene, or you could instantiate it. We probably want to go ahead and have it sitting there. That way we can position it exactly where we want it to be positioned. So we're going to need something that actually is going to be in the background, right? But going to come up. So we want it to still be hiding in the box, but be behind it. So we need that element. So let's decide what that's going to be. What are some of these things? It's like, is that flowers? All right, so baby eats flowers when baby gets power-ups. Perfect. Or we can go the kind of the drug route with it. It's firegrass. That's what zombie babies would probably eat. Brains. Oh, that guy was a lot smaller. All right, so let's turn our power-up container on again, the render. And then we're going to make, we're going to call this firegrass. And we'll go ahead and position this. For right now, I'm actually going to put the layer as, actually I'll make it the same layer, so we'll put the layer as 2. And now it's on top, just for positioning. Okay, so let's just get it showing up first. Now I do have part of my Mario assets here. I have a power-up sound. All right, so we're going to go ahead and attach that to our script. Public audio clip, power-up sound. And I'm also going to give myself private audio source audio. And then in start, we'll say this dot audio dot get component audio source. Okay, so let's go add an audio source to this dude, and then also add that clip so that we'll have that capability of playing the one-off. So we're in our power-up container. We are not going to play on awake. Now it's also looking for a power-up sound. So go ahead and drag that sound in there, just in case we want to have this guy play other kinds of sounds. But right now he's just going to play power-up sounds. Because you think about Mario, there might be a couple different types of power-ups, right? Sometimes there's the thing that lets you shoot the fireballs, and the thing that lets you
star.
Yeah, the star, it makes you invincible. And then you have the cheat flying one, and that's in Super Mario Bros. 3, right? Where you can just fly all around. Like it's not a big deal. Yeah, that's how you collect the magic whistles. You never played Mario 3?
It's a lost time.
Interesting trivia. So, like when new video games come out today, or new software, how is it announced? Usually you see a YouTube clip or a commercial or something like that. How was Super Mario Brothers 3 announced?
Amazing.
Yep. It was in a movie called The Wizard. It had Fred Savage in it, was one of the actors. And it was about, this kid traveling across the country. He was like a video game genius going to like the big world championship video game finals thing, whatever. And the finals was a game that none of them had ever seen. All the other things were, and that's when they unveiled Super Mario Brothers 3 in a movie. They don't do stuff like that anymore. Well, I guess technically Backstreet Boys made their comeback at the end of the movie last year. Wasn't that this is the end? Yeah, Backstreet Boys announced their comeback tour at the final credits of a movie last year. See, they're still doing it. Probably only Brendan knew about that. All right. So we'll have this guy appear, first of all, and let's leave him in this layer. That way we can see him appear, just to know that something happened. And then we actually want him to do something, over a period of time. So I'll come in here, and we'll go ahead and we need to have this guy have access to our Firegrass. So we're going to have the game object for our Firegrass be a public variable inside of our power-up container. All right. And then we'll connect the two. So even though the Firegrass is a child of our container, this programmatically gives them a link. So power-up container now wants to know about the Firegrass. So we'll drag that game object in there. All right, so we have that guy. So now when we jump up, I'll also, for right now, turn the sprite render off for the Firegrass by default. And we'll have it off for the container as well. So now in here, when we notice that we've collided with the player, we'll go ahead and we're going to turn our sprite renderer on, but we're also going to turn the Firegrass sprite renderer on. Okay, so both of them enabled is true. And because of the way we have layering right now, we should see the Firegrass in the foreground. Okay, so now let's switch it around where we're going to see the Firegrass actually in the background. And since we now we can play around with that idea of how we added them to the scene. What might be safer is to go ahead and say the power-up container is actually in sort layer 2. Well, actually, yeah, it is in the order in layer is 2. That'll make it the most forward right now. And then the Firegrass will be a 1. So now when we do this, we should not see the Firegrass. It'll actually be behind the other one. All right. It's there. It's just hidden. So now what we want to do is we want to start that motion of having the thing rise. Okay. Now, what I want to do here is I want to look at what's the length of this power up. Okay, so this guy is a little less than a second. Just like half a second. Okay, 0.584. So that's the amount of time it takes to do that. So why don't we go ahead and have our dude lerp over that period of time. Now we need to have it. Well, we can either have it lerp or we can just have it move. We want to move it between two positions. So let's look at our code here.
Learn actually just work with the like constant rate, so like you can actually specify the time.
Yeah, you can. You can do that with translate too. At least I thought you could do it with translate. We'll just write a function here for making it move. But lerp might be better anyways because it'll kind of be slow there at the very end. That might look better. Show power up will be the name of this function. So for show power up, let's go ahead and have this guy actually turn on the renderer for this dude, just to kind of compartmentalize it. So we'll make him in charge of that, and we'll go ahead and have this dude call show power up. So we will turn on the renderer for it, and we know he's behind. Now we need to make him move in an upwards direction. So we'll say, lerp is a child of the transform, right?
Mm-hmm. It's a child of a vector.
Oh, so position. Well, he wants that. He wants a vector, but does he? How do we get to the? Oh, it's vector 3. It's the top level.
Yeah.
So vector3 dot lerp. Okay, and so we're going to go from a current position, a destination position over an amount of time. Okay, so we know the amount of time was like the 0.587. Actually, this is in a direction first, right? So we're going to say vector3 dot up. And then the next one is it linearly interpolates between two vectors. So we do want the current position of it and the destination position. So we'll have to figure out what that destination position is. So current position is going to be this dot firegrass dot transform dot position. And then for, I'm going to put in that same thing again, but we're going to change it in a second just for a placeholder. Transform.position, and then 0.587F. I think that was the time. Let's double check that real quick. But what I actually want to do is I want to put a second firegrass in there that shows its final position to give me that position tracking. And then I'll keep the renderer off for that guy. And that way we know where we want to take it to. We want to take it to that position so it's sitting on top of it. So that sound is 584. That's the length of that clip. We might actually also be able to grab it from the clip itself. Can we say this dot power up? Oh, I see I've introduced some errors up here. That gets us the length as a float. So that should give us the length of that sound in case we swap out the sound for something else rather than hard coding in the length. Okay, and now I'm going to go ahead and put a second version of our firegrass in there with our final position. So here's our first version, and I'm going to go ahead and turn the renderer back on for that. And I'm gonna make a duplicate. Call this Firegrass destination. We'll go ahead and place that guy on top. Okay. And then I'm going to give myself the public variable in here for the destination. We'll go ahead and connect those two up. Okay. And then in here, this is going to go to Firegrass destination as our destination. So we'll start wherever the Firegrass is. We're going to go to the destination over this period of time.
Back.
Huh?
We'll return back to the spot. We'll just keep going up and down.
Oh, well, no, it shouldn't.
No, it should go up and stop.
Yeah. Because it's just going, we're going from a position to a position over this period of time. We also want to play the sound, right? This dot audio dot play one off, play one shot. This dot power up sound. Okay. And then we'll go ahead and start our sprite renders turned off. Now notice we're never turning the destination one on. The destination one's just a placeholder for us. Okay, so let's see what this guy looks like. Oh no. It's not lerping between those positions. Just for a moment, 0.5. Just do it 0.5. Just make sure we're getting that time. You see, it's not calling the sound either. So, oh, no reference object not set to an instance of an object. Audio. Oh, did I never connect the? Oh, I never added the audio source. Let's go back in here and let's turn this back into the length. Power up container. Oh, he has an audio source. Oh, audio. This dot audio equals this dot get component. I ran the two together. So I'm setting my local variable audio equal to the audio source component of the dude who owns the script. All right, so we played the sound that time. So that means we tried to lerp.
you just set your player grass transform dot position equal to that vector, to your lerp vector. That's why it's not doing it.
My lerp vector.
Yeah, if you go back into your script where you have vector 3.lerp, you need to actually set that to something. So you need to set this dot firegrass dot transform dot position equal.
Oh, because that's the final lerp. So this is where I'm starting from, and this guy goes to this position.
Yeah.
That's going to be his new position. So we're going to calculate his new position over this period of time. But actually, with that in mind, shouldn't this be inside of an update?
No, it's working in mine without it being in the update.
Let's think about that. So it must be that lerp has its own updatey thing built into it, where because otherwise this is going to return the final position unless this does the animation and then ultimately throws you the final position of where this guy is going to live. But that doesn't make any sense either. Let's look at the documentation of this, because this guy should have his final position. We should be able to ask a firegrass where he currently is in the scene at any point in time. All right, so I guess let's see it work here first, and then we'll figure out why it works. This dot power up sound dot length. Did that actually move, or did it just put it there? Seemed to go pretty quick. Let's just slow it way down. Do it over 3 seconds. Just to make sure we see it, rising. No, that's popping right up. Is yours doing that same thing, just popping right up?
I feel like in the other game that I had, it was kind of a little bit smaller.
Yeah, see, I think that's where it needs to happen. Let's look at the documentation here for lerp, because that's where it needs to happen inside of, I think, an update. Interpolates between the vectors A and B by the interpolant T. The parameter T is clamped to the range of 0 to 1. So 1 would be the final destination. So find a point some fraction of the way along a line between two endpoints. Okay, yeah, so this really intends for it to be inside of an update. Let's look at transform.translate. So it moves the transform in the direction and distance of translation. If relative to is left out, relative to is the space. This is the space.world versus relative to your local position. The movement is applied relative to the transform's local axes in world space. The X, Y, and Z shown when selecting the object outside the scene view if relative to So that there's multiple versions. So here's the one that, well, that's the translation. Is there one that gives us time? So it seems like lerp would be the thing to use, but we're not using it correctly because we would want to lerp inside of update over a period of time based on the percentage done we are. So we're lerping between 2 points, but we need to determine. So lerp would get called over and over and over again, and on a per frame basis, we would calculate where we currently are relative to our destination and decide what percent done that is and lerp that much more, that much more, that much more. So we're lerping a little tiny bit, where in this case, because we've given it a value of, what did it say, between 0 and 1 or point? So when we gave it a 0.5, that said it was only, did it only get to halfway up? So we really want to do it over that period of time, not necessarily at a speed. And lerp isn't going to let us Unity translate game object over time. Move from one position to another position in X seconds. Yeah, so they're doing this with a lerp. And each time they're adding to this accumulation variable. The current change in time since the last time divided by the time to reach target. So they're just breaking it up into those chunks over the frame rate. So if you say you want it to be 0.5 seconds to get to the target, then each time through it's going to look at what was the change in time since the last frame. That's the delta time we talked about last time. Divide that by the time we want to reach the target. So that's going to tell us what chunk we need to move next. And then we'll lerp from our start position to the target position at that t, which is going to be the fraction of the distance that we need to travel next. So we're lerping toward, not lerping to. There's no way to do this over a... So I'm thinking about the side effect of this. So if we move it into update, it's not the end of the world, but update, that means this guy's getting called multiple times. So when I do this and I lerp once, doesn't look bad, right? I mean, it pops up quick, but it doesn't look wrong relative to the speed of the sound. But we've decided that it's not accurate, because I think right now, do I still have it set at 3 seconds? Yeah, I still have that set at 3 seconds. Clearly, that's not happening at 3 seconds, because this guy right here is what's known as clamped to a value between 0 and 1. So a 3 is equal to a 1. That means you've reached your destination. So with this, I don't think we're going to see a different. We probably wouldn't see a difference here between this and if we just set the Firegrass destination dot transform dot position. Those might look the same because we're seeing it over a single frame. If we literally just change its position. Yeah, I would say that pretty much look the same. So, because I mean, this is just what our eyes are doing based on frame rate. So we said it used to be here, now it's here. Because what did we do? We lerped between this point, and we're already at the destination. So we did an interpolation of 2 points over no time, or over 1 frame. So it didn't necessarily make a difference. So from a decision-making perspective, this is, if we decide this looks fine, this is actually then probably the best performance. If we really wanted to get that calculation over 0.5 seconds and we moved this into update, we can do it. Just calculate the fraction of because if we're moving at 60 frames a second that means that we should be able to lerp over 30 times, right? So we're basically breaking it into 30 little chunks for how far it's going to move each time. If we do that, that's okay, but that means that we have to put in the logic into update that's going to deal with that for those 30 times, but then also ask the question on every frame. Should we be lerping, or are we already at our destination? My feeling is that's probably an unnecessary burden to put on update. As the game gets bigger and bigger and bigger, that's going to become more problematic. And if the end goal is for us to trick the end user, this is probably sufficient. Now, having said that, after that guy pops up, what usually happens in Mario? He starts moving, right? So we're going to push him in some direction. So this is where we might want to then lerp. Have him move to a certain point and bounce off stuff and things like that. Now, I think we can set a velocity so it has a consistent velocity. Unity. I think we might be able to do that right off the bat. So what I'm going to do here is we're going to go to this Firegrass and we're going to set it as a rigid body, because a rigid body is what we can attach velocity to. So we're going to make this guy a rigid body 2D. And this is just on our the normal Firegrass. Okay. And yeah, I think let's just make sure that that doesn't break anything. It does, because we have his. Okay, so now he's there. Now we're going to go ahead and add a velocity to that dude in a direction. So let's have him move to the right. So after we change the position and we play our sound, we'll say this dot firegrass dot get component rigid body 2D dot velocity and the velocity is going to be a vector 2 in this case. So we'll say this guy's going to be a new vector 2, and we want a velocity of maybe 10 on X and 0 on Y. Let's see what that looks like. Now we do have simulated gravity turned off, so what he's going to do when he hits the end of that wall is he's just going to fly in the air, but we'll deal with that once we see it. No velocity. Is that because we have simulated turned off? Let's add a box collider to this guy. We'll turn simulated back on. All right, so now he does have gravity. So he fell and then he got drug into that, we set his velocity once, but that velocity kept slowing down, especially when he nosedived and that had the drag. So we can set his velocity over and over again inside of like a fixed update, something like that. That would reset it every, 30 times per second, something like that. Then we wouldn't have to worry about the drag like that. But this seems to make it go in a certain direction. It's actually kind of interesting. I'm trying to think, how does Mario normally work? I mean, I don't think the mushrooms don't take nosedives like that, right? They never rotate. So if we come onto our rigid body, we can freeze rotation on the Z. So this is the rigid body associated with our firegrass. So if we freeze the rotation on this, then even though physics say he should tip when he goes off there, he shouldn't. He should maintain that thing. And then maybe we actually avoid the drag when he hits, but I think it'll still drag, or at least drag some. Yeah, it's still drug, but we saw it, he didn't do the tip thing. Okay, so now we want to have it go so that he is going in a certain direction. And I think it's okay if we throw in a fixed update to just keep setting his, if he's out, okay, if we will kind of enable the firegrass. Okay, so we see it now, and as long as that's enabled, we'll just continually set his velocity to 10 to fight back against any friction. And then we want him to be able to bounce off things and come back, because that's what happens in Mario, right? If the mushroom hits a pipe, it then turns back the other direction and bounces back, right? So we see it change direction. So we'll go ahead and give ourselves a private variable up here. This guy will be a bool. Is firegrass enabled? This will start off as being false. And then what we'll do in here, when we show the power up, we'll say this dot is firegrass enabled equal to true. And then to this rigid body, we're going to move that code into a fixed update. What's the difference between fixed update and update?
Update is that you every frame. It's update, I'm not sure.
Like 60.
Yeah, it tries to make it 60 frames a second. So update is going to be different on different performance machines. Fixed update should be the same on every machine. All right, so now inside a fixed update, we'll just keep setting its velocity to 10. So as it angularly drags and its velocity gets to 9.3 or something like that, 30 times every second, we're going to be just resetting it to 10, resetting it to 10, resetting it to 10. So, it won't always be exactly 10, but it should always be pretty close to 10. Okay? But we're only going to do this if our firegrass is enabled.
There's no way just to turn off friction.
Well, you can set friction down to like 0.001, so it's almost not noticeable. So the longer the firegrass is out, the slower it'll get. But whether it'll be perceivable by us or not.
Well, I think a Mario eventually will fall down, so you lose the.
Yeah, you're right. You're right. So you can make that decision based on your game. Whether or not you want to. But I think in either case, a decision is being made, because in either of those cases, the friction is being checked, right? So I'm not sure turning it off necessarily helps, except that I guess you would be checking one thing instead of two. This is a pretty, convenient check though. Is firegrass enabled? If it is, that means it's out. Then go ahead and set its velocity to, for right now, 10. We're going to change this here in a minute. All right, so now gravity, my baby fell off. It happens. But now, since we just kept resetting its velocity, it wasn't able. I mean, it's falling, but ever so. So we probably want to mess around with mass a little bit on that rigid body, right? So we'll come in here and let's try auto mass and just see what difference that makes. Not much of a difference. Now, one thing we could do, and probably should do, is slow this down a little bit. Maybe make it a 5. This 10 maybe was a little quick. All right, so now we need to increase the mass quite a bit to give it the effect that we want. So rather than auto mass, let's give it a mass of maybe 100. That didn't make it drop much faster. We can do a higher gravity scale. Well, let's keep making its mass bigger. That's 100,000. If that doesn't make a difference, we're going to mess with gravity scale. Just to make gravity impact the guy a lot more. That's interesting. Yeah, now it's fought its way right through the ground. So let's set gravity scale to 100 and turn auto mass on. All right, so let's do 30. Not horrible. Probably could have gotten away with 30 and maybe a speed of 7. We'll probably make it look all right or close enough for darts. Looks decent enough. All right, so now what we want to be able to do is we want to be able to have some bumpers there for it to, bounce off stuff. Now, this guy's already a rigid body, so he knows how to interact with some things. So what we want to be able to do is we want to be able to put, for right now, we can put some posts down here or something like that for it to bounce off of, so that it actually knows how to come back the other direction. All right, so when I hit this and it goes this direction and it hits something over here, I want the thing's a lot more powerful than the baby is, by the way. Then I want it to go back that other direction and keep bouncing back and forth between those points. That makes sense? All right, so you can decide what you want to put up there. I mean, you might... what I might do here is just throw in a couple of fence post things just as placeholders, since we've been kind of using those. So there's a fence post, and this guy is going to be 10 by 10. And then maybe give us one more of those. Okay, and now what you want to do is you want to effectively have your, and let's go ahead and add rigid bodies to both of these. And box colliders. Might need to lift them up a little bit too. All right, so now rather than the firegrass thing just plowing through the thing, when it hits that, we want it to change direction. When it hits this other one, we want it to change direction and bounce back and forth between those 2 points, similar to what our, I don't remember what they were, that little king guy, whatever he did. Make sense? All right, so for Thursday, bring yours up to date with this, but have it bounce back and forth between those 2 points. Shouldn't be very difficult the way we've implemented this so far. All right, I will see everybody on Thursday. Don't forget, student, faculty, staff Bible study is today at noon. Free lunch. Just go to the cafeteria, sign in, take your tray down to the terrace room, God and grub. And I'll put the Bible homework up probably in about an hour and a half after my next class. All right.